And so the session now is being recorded, at least if Collaborate Ultra technology works. And so it is being recorded, and I have somebody to talk to, which is Derek, and he could hear me. So I'm assuming that other people could hear me as well. So I guess that is good. Okay, so we're going to start this, and you know, a lot of times I don't feel good about what we're. I mean, I feel as good as I can. I think we're doing as well as we can, and I think it gets the job done. But sometimes I'm frustrated at not being able to walk to the classroom and do this. But I got to tell you, this morning, I think it's a little bit of a blessing that we have a great mechanism in place. And I think even whenever I start teaching in the classroom, the whole time I'm going to say, and if there's a snow day, there are no snow days because we can do it this way. So this is a little bit of a blessing, and I guess I'm a bit of a glass half full kind of person, but yeah. So anyway, what I'm going to do is throw up a PowerPoint slide, which means I have to be sharing something with you. So I will share an application screen. And again, Derek, you just have to shout out if I'm not showing you what I'm claiming, and I'm not there yet. So I have to go to this thing, this file. Okay, and Derek and everybody else, you should be seeing a PowerPoint slide here in front of you. And so these are some of my talking points, and this is what we're going to be doing. At least this is what my plan is, what we're going to be doing during the period together. Okay, I'm going to talk about 4 things here at the beginning. No, maybe it's 5 things. 1, 2, 3, 4, 5. I'm going to talk about 5 things at the beginning. Okay. And I don't know how long this will take, probably not so long, but I will talk about the 5 things. And then I am going to poll each and every one of you the way I've been doing, because I think it's a good thing to do. So I will call on you and, you know, ask you how you're doing, and, you know, do you have any questions and things like that, and you know, that'll be we'll do that. And if I'm doing a good job, there might be not many of them. If I'm not doing a great job, maybe there's a bunch of them, but we'll deal with those and things like that, so that will be good. And then we will do some content during this lecture. I am recording it, and we'll be doing some math here, and that's kind of the whole thing. So let me begin with the thing that I called tools for rules. And here is what happened. And so the last time we met, I talked a lot about all the rules that we have and everything else. But after that meeting, there was an additional tools for rules that was shared. And I think I probably can. Now I'm showing you something here that's actually not what I want. Okay, so I'm going to go back to the other PowerPoint slide. I think to actually show this, I will have to open up another window. And so I am opening up another window. Now I'm still sharing, so you can see the window I'm going to. And I am going to go to COD mail. And again, Derek, as long as you know, you can kind of say, yeah, he's getting there. It's all good. You don't have to say anything. So I'm going to COD mail. Then I have to log in, because I am going to show you an email that I got. Okay, and so let's see. This is going to be then, of course, COD has dual authentication, because I'm actually talking to you from my bedroom. Usually I am talking to you from oh, the Learning Commons. But here I have to do authentication. And so that means I will get a call. So I don't worry about that. I get a call and I answer it and I say, yes, it is me. And so then here we are with emails. And you can see I have a lot of emails. I have in excess of 80, almost 8,300 emails. But I'm going to look in this folder for an email that says tools, or maybe it just says tool. I'll see if I find it. And there it is. Okay, so this is from the Dean of Students, who is Natania Montez. She is a friend of mine. And this is what Nathaniel is saying to you. And I will just read it so you don't have to read it. I am pleased to announce that students are now able to check their own cleared, not cleared status in My Access. And this is under the academic profile, under My Profile. And sample views are shown below. Now, as a reminder, faculty can see this as well, and she's attached guidelines for what orders she's giving me to do. Now, this doesn't have much to do with math, but it is important that we keep people safe and things like that. So I already told you what I was going to do. I'm going to, whenever we meet in class, I'm going to hand out pieces of paper to everybody. That will help me know your names and stuff like that. So that's good. So I will shout out names. So for example, Derek, I will say Derek, and then you will raise your hand and I'll hand you a piece of paper. Now, Derek's piece of paper will either say he is cleared or he is not cleared. And the college is insisting that I do that. But here's the news, and here's why I'm sharing this with you, is that means that you can do this yourself. And what I'm going to do is I am going to cut this because it has how you can do it. And then I'm going to go back to the PowerPoint slides that we were just looking at. And underneath this, I'm going to include this so you know it actually will live here. So I'm pasting this here. And so what you can see is both the rules that Montez is saying that you can, Nathania is saying that you can do. And here you see a Mr. John Doe, that's a hypothetical student here, but you can see that this John Doe is not cleared. Now it also shows up his student ID. So that is that John Doe. Now in Nathania's email, she also has, you might say, wait a minute, this is still John Doe. Well, this is a different John Doe because the student ID is different. And I do bet that there are a number of students who are John Does at the College of DuPage just because it probably is a common name, but these are two common names. But you see, what you can do is you don't have to just come to class and learn, and I mean, certainly you can come to class and learn from the piece of paper that I hand you what your status is. And by the way, that can change, but you also can go here, and I'm trying to create a slide here that has that information on it. But you see, you can check to see if you're cleared or not cleared. So it doesn't have to be a surprise. And if you're not cleared, you want to figure out, okay, so what are you going to do about that, and so on and so forth. Okay, now I certainly want to hear questions that anybody may have about any of these things, and I am going to be polling you for questions. But I think it's worth at least on this point to ask if there's any questions out there. I'll count till 10 Mississippi. To see if anybody wants to raise any questions. And if not, we'll go on and talk about these other things, which actually will probably go quicker than that. Okay, I didn't hear any questions, and I'm assuming that people are still out there. So that's good. So you have a new tool, and I've announced that. So that is good. Now, as I was preparing some remarks for today's in-class session, it occurred to me that some students might be listening to what I'm doing and say, well, what the hell? I thought this was a calculus course. And it is a calculus course, but I will also tell you that the name of the course, the official name of the course, and the syllabus is called Calculus and Analytic Geometry. So for example, and I don't know how far we'll get today, but it's possible that we'll get as far as we'll be talking about vertical asymptotes today. And some students say, well, asymptotes, that was like analytic geometry. Yeah, but we're supposed to talk about it. So the title of this course is called Calculus and Analytic Geometry. I'm not throwing in, actually, I'm trying to make it as good a course as I can, but I'm also teaching you things that are well in line with, what we want to do with the course. Okay, that's all I plan to say about that, but that occurred to me that some students might be confused by that, so now they don't have to be confused. Uh, Students sometimes ask me questions in emails, okay? And I showed you I have 8,300 emails. And again, I'm working through them, and I also try to do priority things, and students have a priority. But sometimes a student will ask me an individual question that really is just their individual question. And I'll give you an example. This is not a calculus student, but this is a student from my discrete math course. And he was talking, and it was a he in that case, and he was talking about, gee, there were all kinds of these articles and books about how to do proofs, and we do proofs in my discrete math class. And he said, so should I be studying these and things like that? Well, it turned out that was kind of a one-off question because this guy was asking it, but other students weren't. And my experience tells me that that's probably a one-off question. So I did answer that question for that student. And basically I told him that I was probably going to teach a rich enough course that he should just hold on and focus on the course, and he could do all that extra reading, some other time. But I didn't want him to lose focus on the discrete math course. But there are other times when individuals ask questions that I evaluate the question, and I'll say, oh, that's a question that's best answered as a group. So sometimes I'll send out an email and say, oh yeah, like for example, if some student asks me, when are your office hours? I've already told you that, but I'm not just going to say that. I probably would say, oh, some students don't know when my office hours are, so I'll rebroadcast that answer. And when I rebroadcast that answer, I think I've answered not only the individual student, but I've answered everybody, maybe some other students' questions as well. Okay, so sometimes there are individual questions and group answers. Sometimes there are individual questions and individual answers, and I answer them as I get to it. But you are a priority for me. Uh, you are one of several priorities, but you are a priority for me. Okay, that's all I plan to say about that. The next thing I say, expectations are both videos and classroom materials. Yeah, when I post a video, I'm expecting that you have looked at it, and I'm holding you responsible for that content. So please realize that that's my expectation, and in fact, I work pretty hard to make sure that the videos are not redundant. And again, sometimes I have to talk about the same stuff, but I think they're unique learning experiences. And so, for example, in class today, I expect to state the um, intermediate value theorem for continuous functions. I am not giving you a video where that is stated. So to get that, you're doing both of them, and again, I'm happy about this not only because we don't have to have a snow day today, but I'm happy about that because I told you once upon a time that my number one thing was trying to teach you the best damn course I know how to teach, and I have a lot of things that I can say, and that way I can share more with you, and you can learn more that way. So anyway, please understand my expectations are you're looking at both of those, and I am letting you know in the course announcements, things about that and so on and so forth. If I were doing this over again, I would probably mention Linda Shaw's guided study groups and encourage you to think about attending those as well. But I don't have that as a specific an explicit talking point. Now, The next thing is an important talking point for me, and it's called office hours and special meetings. Now, a lot of times I meet with students on Sundays and Saturdays, particularly in the Learning Commons, when the Learning Commons is available. And sometimes students say, "Oh, I am so busy." They're saying they are busy, and I have to trust that yes, they are busy, and I can't come to your office hours, and so we need to schedule something special. And I do this almost to a fault, but I do schedule special meetings with individual students. And that's why I support Linda Shaw and having those special GSG meetings and things like that. But I do have a bunch of office hours per week that are designated. They are Zoom, and they are face to face. And whenever we start being face to face, those will get the times won't change, but I'll just underscore how that's going to be. But so far, my office hours have had Zoom visibility. I have had exactly one student who has come to my office hours this term. Now that's all right, because last term I had 4 or 5 every office hour and was very busy and very frantic. And so please don't feel, oh my God, Jim is lonely, so I have to go there. I don't stare at an empty Zoom screen. What I do is I log into Zoom, because I've told you I log into Zoom, but then I have work to do. So I just am sitting here doing work and drinking coffee or whatever I am drinking at the time, and so I'm happy. You don't have to come to keep me company, but if you do have questions, those are wonderful times that I have set aside to meet for you. So if you and again, those are in the announcements. But again, this morning, no one came to my office hours. So please know that you are welcome to come to my office hours. We have whiteboards and things like that. It is possible you can come to my office hours to talk about private things if you want to, but for the most part, this is about math. Although I can set up, and maybe I'll set up, I haven't done it yet, but I could set up passcodes, so if we need to talk privately, we will. I have had students who came, a student from, let's just say, differential equations, who showed up and they had a personal issue that they needed to share with me. And then a student from my math for ultrasound showed up. And what I would say is, hello, I'm glad you stopped into my office hours, but the student who is not in your class, but we're having a private discussion right now. So I'm going to take your contact information. I'll reach out to you separately and things like that. But anyway, my office hours are there for you to use. I've got a lot of office hours, and I'm willing to do special meetings with people if they can't attend my office hours, but that's what my office hours are for. Later on today, I'm going to show you some slides that I made during my office hours, and I think what I can do is I can pointing up in the corner and say, oh yeah, that was my Zoom screen, because I was just sitting there in case somebody came, but I was doing math while they weren't there. So anyway, office hours are useful. I'm there for you to use. I am willing to have special meetings if that's what you require. And that can be, dealing with questions or whatever. Okay. Okay. I'm about ready to do the polling. And so we'll do that, and then finally we'll start talking about math. I know this takes a long time to do this, but gee, I'm posting videos for you, so I'm not worrying about that we're not where we need to be. We're in good shape as far as covering the content of the course. I am not worried about that. And this polling, I think, is useful during this complicated times. So now I am stopping sharing this PowerPoint slide show for now, and I'm going to, that's not where it is. I'm going back to here, and so I stopped sharing. And I'm going to look at the students, and I'm just going to go down the list. I am going to call on everybody that shows up in this list. If your technology is working and you're inclined to do so, feel free to go, I guess, on mic and respond to me. And if you're, and then someone just dropped off. Maybe they'll come back. We'll see. But anyway, okay, so I'm just going down the list. So you will have an opportunity to share things with the group, and I hope that student comes back eventually. Okay, and by the way, I don't keep track of what happens. People have to let their dogs out, and people have to change diapers, and so on and so forth. In fact, Linda Shaw has had to let her dog is named Seven, has had to let her dog out before during a class, and so that was okay. All right, I am starting with Alex Fenton. And so, Alex, how are you and yours? And do you have any questions at this time for me or the group? So Alex, and I don't know, you might be still on mute, or I don't know what's going on. He might be taking his dog out too. So Alex, anything?
I'm all good. Sorry about that.
Oh, no, and don't be sorry. It's just I'm calling on you because I care about you. Okay.
Yep.
All right.
Thanks.
So Alex is good. Let's go to Artemio.
Uh,
And again, how are you and yours? And do you have any questions or comments for me or the group?
no, I'm fine, thank you. I don't have any questions.
Okay, that is good. Okay. The next in this list is, wow, somebody else dropped off too, huh? Okay, let's see. Next on this list is Cecilia. Cecilia, how are you and yours? And do you have questions you want to raise with me or the group? And also, Cecilia,
Yeah.
sometimes what can happen is somebody can have an individual question, and that was one of the reasons I talked about and I'm not talking to Cecilia now, I'm talking to anybody, but you're welcome at my office hours, and I can set up special meetings and stuff like that. So, those things are there. But so anyway, Cecilia, I thought of that as I was talking with you. So anyway, Cecilia, do you have any questions for me or the group? And how are you and yours? You guys doing okay?
First of all, I'm doing all right. Second of all, remind me what the times are for the office hours. I forgot.
Okay, and that's good. And I am going to remind you of the times. Okay, and I am not going to quote the Zoom addresses because in fact, here's what I'm going to do. I am going to answer your question about the times. Okay, and I am going to republish. And I need to remember to do that, but I will have time to do that after this class. And so I will republish in the announcements the office hours, and sometimes those things have to do. Okay, so here are my office hours then that I have. And by the way, the College of DuPage is weird because, well, the College of DuPage is weird. I can just stop there and not explain why. But academic hours are considered to be 50 minutes, and I have 10 of these hours a week. So what happens is I am available for office hours. This is the times of the office hour is Monday through Friday. So that's 5 days a week. I have office hours from 8 a.m. to 9:15 a.m. Those are both a.m. So it's 8 to 9:15, and there is a Zoom address, and I'm going to republish those, Cecilia, again in the announcements, okay? Because somebody might say, I have to look through all the announcements to find those. Well, I'll give you one that's closer on that. And that's actually more than an hour because 8 to 9:15 is, well, it's whatever it is, 75 minutes, and an hour really is just 50 minutes because of the way the College of DuPage counts things. But anyway, that's 75 minutes that we have. And then in the evening from 9:30 to 10 o'clock, I have evening office hours, and these are on Zoom, and that's also Monday, Tuesday, Wednesday, Thursday, and Friday. And again, there's a Zoom address for this. And if I add that's 30 minutes, and if I add the 30 minutes to the 115 minutes, you have more than 100 minutes that I'm offering for you per day. Now, I want to stress though that I'm very happy to, you know, and I do sometimes have students say, you know, Jim, I just can't come to those. And, you know, I just take them at their word. I don't say prove it. I just say, okay, so when can you meet? And we schedule something. But that's, I've set aside that for that. Okay, so Cecilia, any other questions? Or are you good with that?
No, that's it. You also answered where I could about the thing about the link and where I could meet you by saying that thing about the Zoom.
Yeah, there is a Zoom thing, and I am going to at least, I hate making, I really never make promises that I don't intend to keep, but sometimes I forget things. But I'm probably going to send out a thing and just say, hey, you know, just reminding you, here's my office hours and here's the Zoom links. Okay, so that should be in an announcement and in an email soon. Okay, and so Cecilia, you said that you guys were okay, so I'm moving on then. Derek, you are next in this hit list, and again, Derek, I really appreciate you being my I don't even know what to call it, my point of continuity for well, there's the word we're talking about, my point of continuity for this lecture. So Derek, how are you and yours, and do you have any questions or comments you wish to share with me and the group at this time?
I'm doing good, and I don't have any questions at the moment.
All right, excellent. Thank you. And again, it's excellent if you have questions too. I mean, that's why we're doing this, is to deal with this. Okay, Hare Patel, how are you and yours? And do you have any questions or comments you want to deal with me at the present?
I'm good and I don't have any questions right now. Thank you.
Okay. Okay, excellent. We're moving on to Jeffrey. And this is a little bit unusual. There are no duplicate names here. This, I mean, it is good. So I could just call you, you know, things. All right. So Jeffrey, how are you and yours? And do you have anything you want to share with the group?
I am doing all right, and I don't have anything to share right now.
Okay, excellent. Let's go to Joseph then. Joseph, how are you and yours? And any issues or questions you want to share with me and the group at this time?
I'm doing good. I don't have any questions either.
All right, excellent. Let's go to Kang Lee. And Kang Lee, how are you and yours? And do you have any questions or issues you want to share with the group today?
Sorry, you mentioned my name.
I can hear you now. Yeah, sorry. Do you have any questions or comments now? And
No, it's very clear for me. I'm good.
okay, so that is good. He is fine. Let's go to Mark, please. So Mark, how are you and yours? And do you have any issues or questions or comments you want to share with me in the class at this time?
I'm doing good, and I have no questions.
All right, that's of course fine. Let's go to Michael, and Mike. Now I have to look. I have a Michael in another class, but it's actually spelled differently. But anyway, this is our Michael. Okay, so Michael, how are you and yours? And do you have anything you want to share?
No, I'm good.
Okay. All right, great. And I'm going to say last but not least, there was a student who was here and left, and if they come back, and if I remember, I might ask them. It's not that I don't care about them, they're just not here right now. Okay, let's see, we go to Tony. Tony, how are you and yours, and do you have anything you want to share with the group right now?
Hi, I'm doing well. Thanks for asking, and I don't really have anything to share or any questions right now.
Okay, excellent. So that's the end of the list. Your questions, of course, are always welcome, and just shout them out, I guess I'm going to say. Okay, so now with all of that done, I'm going to share my screen again, and we're going to go back to my applications screen, and eventually, very soon. Now it tells me my connection is bad. That could be because of the snow. I don't know. And Comcast didn't bury their stuff very deep in my yard, so we'll see what happens. Okay, so here is, okay, so you should be looking at a thing, at a PowerPoint slide. And again, Derek will tell me if we're not. And there's the thing that I showed you about the new tool. And now we just go to this. And now I am going to discuss with you the intermediate value theorem. And this is called the intermediate value theorem for continuous functions. And this is an important topic. Whenever you look at things that students are supposed to learn in this course, the intermediate value theorem is, right up there. So anyway, and here it says it's an important theorem. It of course is. So what I'm going to do is, and maybe I can make this a little bigger for you. I don't know if this really makes it bigger or not. I don't know if that's bigger or not. But anyway, here we go. So this is the statement of the intermediate value theorem. If f is a continuous function on a closed interval AB, and by the way, in the video I made, and I don't expect everybody has watched all those videos yet. In fact, some of you say, damn it, you just posted a video this morning before class. Well, yeah, I did. But what I'm really going to tell you is when you watch that, you'll know that, oh, there's some special properties of continuous functions on closed intervals. So anyway, we have an f is a continuous function on a closed interval AB. And I am telling you that it is important in this theorem that that interval be closed. And if f at the left endpoint does not equal f at the right endpoint, that is f of a does not equal f of b, and if k is any number between f of a and f of b. And you see, that's why it was important that f of a didn't equal f of b, because we're saying, oh, there's some number in between them, and if they were equal to each other, there wouldn't be a number between them. Okay, so k is any number between them, then there is at least one number c in the closed interval AB such that f of c equal k. Now theorems always have if and then parts and things like that, and you really can't just it's not like reading the sports page and it's easy to figure out who won and who lost. You have to really read the box score and have to think about this, but this is the intermediate value theorem. And so you have to think about, what does this mean? So we have some remarks. The intermediate value theorem tells you that at least one number c exists, but it does not provide a method for finding c. Now, later on in the period, we will probably talk about ways that we can find such a c. But anyway, this is a whole class of theorems in math that are called existence theorems, and we just prove that something exists. So, and it does say that you can refer to a text on advanced calculus to find a proof of this, and it's based on the fact that the real numbers are called complete. Now, and in fact, some textbooks, and maybe the textbook that you're, using as this course, a lot of textbooks that are Calculus 1 textbooks, they'll say, oh, the proof of this is beyond the scope of this course. Well, that doesn't mean you guys are stupid and that you can't understand the proof, but there's a lot of technical stuff that's required for the proof. And if I wanted to prove this, I would be spending probably 2 or 3 class periods talking about the proof of this. So I'd have to be introducing a whole bunch of extra machinery and things like that that's, not I'm not going to say it's not useful, but it's we only have so much time. So I'm not going to worry about that, and we'll just say that this is an advanced calculus topic proving this. But it states that for a continuous function, it takes on, and they're saying it in different words here, which sometimes is useful. So a continuous function takes on all values that are between f of a and f of b. Or they said it a different way, I guess. They said if x takes on all values between a and b, then f of x must take on all values between f of a and f of b. And I don't know if this really works, but I'll read what it says here. An example of the application of the intermediate value theorem. Consider a person's height. A girl is 5 feet tall on her 13th birthday, and on her 14th birthday, she is 5 feet 2 inches. Then for any height h between 5 and 5.2, there must have been a time t when her height was exactly h, because what happens is that nature is continuous the way you grow, and so you don't just instantly go from 5 to 5.2. Now sometimes it happens very rapidly, but still there is a time. Okay, and because a person's height does not abruptly change from one value to the other. Okay, so the intermediate value theorem guarantees the existence of at least one number between the closed interval, but there may be more than one. It just says that there exists one. And in fact, with this picture on the, and I think you can see my cursor, Derek, I'm wiggling it over here. On my left-hand side, there's a function, and this is continuous because I can trace it and never lift my piece of chalk. So that's good, and I'm going from A to B, and it's continuous on AB. And here is f of A, and here is f of B, and K is a number in between the two. So if I draw it across that, in this case, there's not just one number. There are three numbers where it equals K. C1, C2, and C3. It's equal to K. So, there could be more than one, but the theorem says there is at least one. And it is important that the function be continuous, though, because here is a function that is defined on the closed interval AB. And you see it's defined everywhere because you might say, oh no, there's an open circle. Yeah, but the open circle, here's a closed circle. So it really is defined on A, but it's not continuous, because to get from here down to here, I have to lift my chalk, and that's a jump discontinuity, or a non-removable discontinuity. But you see here, I can take a K that's between those two, and I can say, oh no, there's not a K that exists. So you see, if f is not continuous, this is, I don't know what the hell this is saying. That shouldn't be there. But anyway, it is important that the theorem's not true if you're not continuous, and we're not going to prove that theorem, although we are going to, like so many theorems, we're not going to prove them, but we're going to use the theorem. Okay. So here we're going to, and by the way, I'm not saying I'm going to ask this on a test, but I could ask a question like this on a test. In fact, I could ask a lot of questions, on tests. So anyway, this example says, use the intermediate value theorem. And in fact, by the way, this is kind of, this is not the way I would ask the question. I would not tell you that you have to use the intermediate value theorem, because that's not requiring you to understand things to the depth I hope you understand them. I would have started this question to say, show that this polynomial has a 0 in the interval 0, 1. Now, one of the things that we learned, and when I say we learned, maybe you haven't learned it yet, but you will learn it, is a polynomial is a continuous function. You can trace a polynomial without lifting your chalk. And so on 0, 1, the polynomial is a continuous function. Show it has a 0. Well, 0 means, oh, there's a place between 0 and 1 where f of x is equal to 0, or where x cubed plus 2x minus 1 is equal to 0. There is a solution there. Okay, now I'm not asking you to find it. I'm just saying, show me that there is a solution between there. Okay, so let's look at the solution then. You see, now, and if you were answering this question, what you would have to say is, well, f is continuous because all polynomials are continuous. I would expect you to say that in your answer. Okay, that's the adult math 2231 answer. So you say it is continuous on the closed interval, and if I plug 0 in the left endpoint, I get a negative number, minus 1. And if I plug the right hand endpoint in there, I get f of 1. I plug all the numbers in, and I get 2. So you see, it's negative on this side, and it is positive on the other side. Since it's a continuous function,
I think you got muted.
I'm sorry. I'll tell you what. I'm going to say what I said, and you may have been asking me to repeat that. Okay. All right. So f is continuous because it's a polynomial, and that's something that we have learned. I taught you that in the videos. If you watch the video, you might remember it. If not, you will watch the video and you'll remember it then. But this is a continuous function on this closed interval. That means, since it's continuous on a closed interval, that the intermediate value theorem applies. And you would have to say intermediate value theorem down here, but what we would say is f of 0. So I'm looking on this side, you see the interval is 0, 1. So if I plug 0 into this, I'm wiggling my cursor underneath this. So if I plug 0 into there and do the arithmetic, I get -1. Okay, so that means that this point over here is on the curve, but that is negative. And if I go to the other endpoint, 1, and I plug in 1 into this, I find out that the answer is 2. So that means this point is on the curve. Well, a continuous function went from being negative here to being positive here. Well, the intermediate value theorem for continuous functions says any point in between, and 0 is certainly a point in between a -1 and a +2. It must cross there. There must be some c in between 0 and 1 where f of c is equal to, in this case, 0. And that's pretty much what the words say down here. It follows, since f of 0 is less than 1, f of 1 is bigger than 1, you can apply the intermediate value theorem to conclude that there must be a c in between 0 and 1, such that f of c is equal to 0, and then f has a 0 in the closed interval. Okay, I'm going to pause for a count of 5, Mississippi. And if if there's questions remaining, you can ask them, and if not, I'll consider this example a success. Okay, I hit 5, Mississippi, which means I'm going to declare that example a success. Now, we are going to talk about, and by the way, and students should understand that if I talk about something, I might ask you about it. So, sometimes students say, well, do we have to know this? Well, I'm talking about it, so I do want you to understand it. Okay, and in fact, there is a method called the bisection method for approximating the real zeros of a continuous function. Now, this only works for real zeros. It doesn't work for complex zeros. But it works for real zeros, and that's a lot of what we're doing. We're doing mostly the calculus of a real variable, certainly in calculus 1. It's actually similar to that example. And so I will say more. So if you know that a 0 exists in the closed interval AB, then the 0 must be in the interval, either in the interval a plus b over 2, or from a plus b over 2 to b. Now what you're really doing is you're cutting the interval AB in half. Okay, so from the sign of f at the midpoint, you can determine which interval contains the 0. By repeatedly bisecting the interval, you can close in on the 0 of the function. Now we're going to do a very real example of this, but on this slide, I want you to understand that your calculator does much the same thing when you use what's called the root button on your calculator. Now, the examples that we're going to do are using Excel, and I will teach you enough Excel so that you feel good about that. But we're going to do this examples using Excel, and I have asked students to do this. I have sometimes asked students as this as a take-home problem, or maybe as an LSA. But anyway, I'm going to show you how your calculator does it. And by the way, I know I've said this before, and now I'm saying it again. But COD calculus, and this is a departmental decision. It is not my decision although I agree with this one. Sometimes I don't agree with decisions, but I agree with this one, is that we really want students not to just learn how to punch buttons on calculators, but actually how to understand calculus. So that's what we're trying to teach you. But anyway, I just want you to know, and by the way, this TI-84, and here you see plus silver, the TI calculators are very good calculators, and engineers may want to buy these. And I've got to tell you, bang for the buck, this is the calculator that I, in fact, have spent some of my hard-earned money for. In fact, the very first calculator I bought, by the way, I was a sophomore in college before I could afford a calculator, but I saved my money and I did buy a TI calculator. Now, this is not the one I bought. I bought something that was like way, way, way older than this. But this is actually the calculator that I spend my hard-earned money for now. I do have a TI-84. Actually, I don't know where it is because most of the time I use Excel or some other program. But anyway, here's a picture of a TI-84. But you don't have to have a TI-84, and in this class, for the most part, you don't get to use it anyway. And by the way, if I ask you to do something as a take-home LSA that requires a calculator, they have calculators like this that you can just use either in the library, in the testing center, or also in the Learning Commons. So, you can have these, that way for free. And I'm not trying to teach you how to use this calculator. I'm just showing, this is exactly what they're doing. Okay, so the first thing, and by the way, TI did a wonderful thing of programming this calculator. They took a program that I used to use on the PC called Derive, and they adapted it, and they had to be very clever because they have to have things to fit on the screen. And by the way, the screen thing is very important. It uses the screen, and if you have something that's not on the screen because you messed up the window or something like that, it'll say we can't do this problem. And so it's a very nice tool, but it's also a reasonably complicated tool, I think. So anyway, I'm taking that equation that that the book was talking about. So this is x cubed minus 2x plus 1, and you can graph it. Okay, so I just graphed it here in this next window, and you had to type it in to graph it. So and I went over here and graphed it, and notice that there actually are two roots to this that are shown on the window that I have. Okay, now the problem that we had wasn't this whole window. It said, oh, between 0 and 1. So I had to adjust the window to have the minimum x value to be 0 and the maximum x value to be 1, and I will get a different picture. And if I change the window, I will get a picture that looks like this down here. Okay, and you see it really is cutting it off. It's saying, oh yeah, but we only go from 0 out to somewhere there. Okay, so that second root really isn't part of the solution here. And so we're restricting ourselves to 0, 1. So we're only going to have one answer. So the graph looks like this, but now I've adjusted the graph, so we're just focusing there. And then there is a button, and wow, I didn't show you that button. Huh, hold on, let me see what happens here. No, I didn't show you the button. Don't worry about it. So there is a button that you can punch, and you punch second on the calculator, and you hit calc, and there's a thing where you can find the root. Okay, but once you do that, and I could have shown you that, and I guess I didn't. But once you do that, what happens is it will ask you a question, and it will say, what's a left bound? And this is a question that you have to answer. Now, in my case, that means, oh, left of, they're saying, what do you know that's left of the 0? And the closer you can get, the better that is. But I just went here and clicked that, and it says, oh, your left bound is going to be, and apparently I was at 0.5, and you notice that y is, that's 1 over 8. Okay, so y is 1 over 8 if I get that. So that's the left bound. But then it'll ask me about the right bound. Well, I have to go to where someone is negative because it has to know, oh, one place it is positive, one place it is negative. That means it's in between the two. Okay, so I went to this value, and it was positive, and I just clicked there. So you see it's asking me to give it the left bound and the right bound. And then it even asked me to guess. Now, if you're looking at what we were just doing with the intermediate value theorem, that's where we're saying, okay, we got A, the left endpoint, we got B, the right endpoint, and then we guess that the root is at the middle. And so I guess, and by the way, I don't guess the root is at the middle. I usually just say, yeah, and take the guess that I have. But then what the calculator does, its internal programming, is it does what we're going to do in Excel, and it uses that bisection technique over and over and over again. And you can see on the left-hand calculator screen here, you can see that it declares that the 0 is. Now, this is not the exact 0. This says that to that many decimal places, and oh my God, that's 1, 2, 3, 4, 5, 6, 7, 8. That's to you know, well better than a millionth accuracy, which is pretty good for engineering work. It's not often you need a tolerance better than that. Although actually sometimes in astronomy you do need really great tolerances. But anyway, that's the rounded off answer. And you see your calculator is really using the intermediate value theorem. And you might say, okay, but suppose I've never done this. Have I ever used the intermediate value theorem? Yes, you did. When you were young in high school or wherever you were doing it, they tell you, oh yeah, pick some points, and you pick some points, and then it says now you can connect the dots smoothly. When you were connecting the dots smoothly, you were using the intermediate value property. And you can think about that more if you want to. Okay, now, so here is a problem that I'm going to do. And we are going to use Excel doing this, and you will want to you know, pay attention to what's happening and so on and so forth. And I'm going to add a comment here, and you guys probably already have this, but COD students get Excel for free with Microsoft 365. And if you've already done that, that's great. If you haven't done that, you should do that because there's a free software that you get, and there's software available in libraries, and almost any PC has Excel on it anyway. And you could ask me or Linda, you know, how to get Excel 365 if you don't. So I'm not introducing any expense to you. I'm just saying you need to, you know, you want to do that. And I am going to copy this also because I want to go to Excel, and we're going to program this, and we're going to try to find an approximate root to this. So I'm just doing this, and I will copy that, and then I'm going to go to Excel, and you see Excel Microsoft 365. You see it's coming up. This is exactly what you will get for free. Comes up. Now I got a lot of extra junk here, so this is going to take a while to open. And I am watching the clock. We go till 10:55, so hang in there. Okay, I will open a thing. And apparently I have a whole bunch of things over here. I'm just going to close that for now. Maybe it won't let me close it. So I will just use it here. I'm going to paste that equation just so I have it, so I don't lose it. Okay, so we have that equation, and we want to find, you know, the roots of that. Okay, and I am going to make the Excel a little bigger. And I wasn't making the Excel a little bigger. I was making here's where you make Excel bigger, right here. Okay, and I am going to pause right now, Derek, to ask, you are looking at an Excel screen now, is that true?
I'm sorry, could you repeat that?
Yeah, can you see Excel?
Yeah, I can see it.
Excellent. And by the way, I wasn't saying, oh, I bet Derek's asleep on the switch. No, I just wanted to confirm that and, just make sure that everybody did that. And again, I'm not asking you to be, active. I'm not going to ask you every, 2 minutes or something like that. But just shout out if I go south on this. Okay. Well, okay. So one thing I'm going to do is I am going to I'll teach you how to do a little bit of Excel programming, and not a lot, but just a little bit, okay? And so if you're putting a function in Excel, you have to type an equal sign, because Excel will be aware that if I'm typing an equal sign, that it's going to be a function, and that wasn't what I wanted to do. In fact, I'm going to lose that for now. I'll make Excel bigger so you can kind of see what I'm doing. Okay, so here I am just going to create this function, okay? And I got to be just a little bit careful about how okay, here's what I'm going to do. And I might go back and erase this, but this is X. So I'm going to have X to be 0 here. And I'm going to have X to be 1. Now I've actually thought about this problem, and you have to think about it a little bit too. But this is going to be the f of X that I have. Now, I didn't put equal signs there, so I'm just typing notes so I know what's going on. But now I am typing this equation, okay? And you've got to be a little bit careful in typing things, but I start with an equal sign because it is an equation. And that means XL is going to be evaluating this as a function, okay? So first thing is, it's going to be a square root. Now there's different ways you can write this, but I'm going to use the Excel function, which is sqrt, which is a square root function. And then I'm going to put some things in here. Now, you see I've got the square root, so I'm going to just put what's under the square root because this is like composition of functions. So I'm going to put, and I'm clicking right here. So I'm taking whatever value is there, that is cell C8, and I'm going to raise this to the 4th power. Now you see what I've done is that's what that little caret means. And by the way, that's the same symbol that's on the TI calculator. It's not universal, but it's a lot of times. If you're doing Fortran and certain programs, you have to use double stars. But anyway, there we go. So that is C to the 8th. Is C8 raised to the 4th power plus. And then I just type plus. Okay, now I have to do that, but this is going to be 39. The way you multiply with Excel is you use the shift on the 8, which is an asterisk. So that's how you multiply on Excel. And then I'm multiplying it times that thing again. And then I'm going to add 13 to that. Then I'm going to close the parentheses because that's the end of the square root. Then I'm going to subtract 4. Now what I've done is I've programmed in that equation there. So I'm just going to hit enter, and I get that. Now the whole point is what happened was Excel took that 0 value and it plugged it into that function. And the big point is that, and I'm just writing some words here. So at x equals 0, the function is negative. By the way, this is a continuous function because it's a composition of continuous functions, and you got polynomials. This is a continuous function. Okay, so we're going to be able to do that. And here's one of the things that is really cool about Excel is that you can, and what you do is you see I got a thick or fat cross here. And you also can see on this little rectangle, I have a little dot on the lower right-hand corner. So what I do is I take the fat cross and I go over that little dot and I get a cross with no arrows. Now, by the way, you can screw this up. And if you screw this up, if I wiggle it like that, I get a cross that has arrows in it. That means something else. But I turn the fat cross into that, no arrows. and then I press down. I am left clicking and I pull it down. And you see that did it for 1. So I can pull down the formula, which is an extremely powerful thing. In fact, this was the thing that made spreadsheets the thing you want to have. And so we also can say, so at, and I'll just do that, but I'm going to go up here and change it. So at x equal 1, the function is, and I'm going to change the word over here to be positive. Okay, so what that means is that there is a 0 between 0 and 1 by the intermediate value theorem. I'm not typing well today. IVT. I think I need some more coffee. So by IVT, there is a 0 between 0.0 and 1. Okay, so you'd like to find it, and let's suppose that you wanted to find it, and you wanted to find it to some level of accuracy. Okay, so that's what we're really going to do then. And I'm going to start programming this again. And again, I'm doing this just to show you how the bisection technique works. And we'll do a little bit of this. I do know what time it is, and we'll be able to do this. Okay, now, and one of the very good things about Excel, it can do, these calculations, things like that, is a very good tool. Also, you can just type words, so it will help you know what it is. So we're building a table. This is going to be the left hand point. This is going to be the right hand point of the intervals. And we're going to be whittling these down, okay? And then here I'm going to do the midpoint. Now, what I'm really doing here is I'm not doing any programming, I'm just typing. So this is the midpoint. And then here I'm going to put f of left-hand point. There's a hair on my keyboard that I had to blow off. Okay, so this is the left hand point. And this is f of the right-hand point. And this is going to be f of the midpoint. Okay. Now, you see, we know that the left endpoint at the beginning of the problem is 0, and we know the right-hand endpoint at the beginning of the problem is 1. And the midpoint, I'm going to write a program to find the midpoint. And I know it's 0.5, but I'm just going to say, okay, so it's equal. I need parentheses, and I'm going to say it is this guy plus this guy. Then I'm dividing by 2, because you see, I'm going to want to pull this down in a bit. And of course, the midpoint is 0.5. Now I need to program this in, and I need to change some things. And by the way, I'm not 100% sure this is going to work. I mean, we'll get where we want to go, but I'm just going to go here, and I'm going to say that this is going to be equal, because I spent some time programming it up here, and so I say that is D8. Now, D8, it's just the number. And by the way, that is what I get here. but I have to go in here and I have to look at the formula for this. And I just said it was D8, which all right, so what I'm going to do is, let's see, I'm going to have to type that. Wait, here's what I will do, I think. Hold on. There's a button that's called formulas, and I can show formulas. So here's the formulas, and I can show formulas. And there's the formula that I have. Now I'm going to try to copy the D8 formula, and then I'm going to try to paste it down here. That, of course, didn't. Well, maybe it worked and maybe it didn't. Hold on. So I'm going to erase this. Bear with me. I actually do know what I'm doing, kind of. Okay, so I was going to copy that. I'm copying that formula. That's what I need to do. I'll copy it up here. Now, I don't want to have the reference for the C. I want to have a different reference, but now I'm going to paste it here. And that's not working, so I have to copy the whole thing again. Damn it. That's all right. It's not that bad. Okay, so I'm going to just say, forget what I did there. So I'm just going to, okay, so I'm just typing the whole formula again. Okay, so this then, not up there, but down here, this is going to be equal to, okay, so this is going to be equal SQRT parentheses, and it's going to be the left-hand endpoint, and I'm going to raise that to the fourth power plus, and this is going to be 39, and this is times, and it's going to be the left-hand endpoint again. You see it's a different C, it's C13 now, and then it is plus 13, still under the square root. So then I close the square root, and then I subtract 4. Okay, now I have, oops. Oh, it's showing formulas, not numbers, so I have to go back and kill this. Don't show the formulas anymore. Okay, and you see I got the same number I had before for that one. But now the cool thing is, what I can do is I can take the very same formula and pull it this way, and I get the numbers for the right-hand endpoint. You see that matches up with what we had before. I actually changed this, and so that's why it wasn't there. But I get the right-hand endpoint, and you see this is using D13 as the input, and here I'm using E13 as the input. Okay, so I get all of those. I'm doing something here that's kind of cosmetic. Don't worry about that too much. And we're getting all kinds of numbers there. Okay, so now what we have is, and then I could say, okay, so then I'm going to write, what is my guess? And my guess is always going to be the midpoint in this case. So my guess is going to be the midpoint, and so I have that, okay? But now you see what happened is I have it was negative, positive, but now at the midpoint, it is positive. So that means by the intermediate value property that the left endpoint is still what it was before. So the left endpoint, or actually the left endpoint is still 0. But the right endpoint can be changed because it's going to be 0.5. So you see, I know I'm between, okay, so I'm between, so it's negative and then it's positive, so that's what I have. This is between 0 and, okay, and I'm going to put the error here too, so how wrong can I be? Okay, so how wrong could I be? And the error is also 1/2 the distance of the A to B over 2. And so I'm just going to say equals, and this is going to be parentheses, and it's going to be the left-hand endpoint plus the right-hand endpoint divided by 2. That's how wrong I could be because I guessed the middle point. Okay, all right, so that is good. So you see at the left endpoint it was negative, and at the midpoint it is also positive, and that means we're in between the two. So I'm going to let this equal the midpoint now. Okay, and so, wait a minute, that's not right. That had to be the midpoint. Okay, so the midpoint was this one. Okay, so yeah, we have that. Okay, so here equals that. So what I've said is that we're between those two values. Now what I should be able to do is do a power scroll and pull all this down. Okay, so you see at the left endpoint and the right endpoint, I have that. That means there's a 0 in between. Now the new midpoint is the midpoint between the left endpoint and the right endpoint, which is 0.25. And when I plug that in, I get 0.87. And so you see what we're getting is this. Now let's look and see. So it is 0 here, and it was still 0 at the, it was less than 0 at 0, and it is bigger than 0 at the midpoint. And my guess now is a new midpoint, but since it is positive at the new midpoint, I know it's between 0 and the new midpoint, and the new midpoint is this one. Okay, so we get that, and then what I can do is I can pull this down again. And by the way, if you were clever programming Excel, you could program it to do this with if functions, but anyway, we're doing that. Okay, so you see, we're getting closer and closer. See, the value of the function is getting lower and lower and lower, and we could keep doing this. I don't know if I want to do this again or not. Maybe I'll do it one more time. Okay, and again, it is still closer to the, so you see the left endpoint is still negative, but the midpoint is positive. So I'm going to do it again. Now it doesn't always work this way. Sometimes you bounce back and forth, but this is going to be the new midpoint. This is the new midpoint. And then I can pull all of these down. I can do the calculation again. And I think I'm going to be tired of this game by doing it this long. Okay, but you see, I'm getting closer and closer to the X value that I want. I know that the answer now is between 0 and 1/8. And we could keep going here. And I'm not 100% sure how eventually I will get a negative for this. And let's do one more. And I'm really am tired of doing this, but let's do the new midpoint. So this is going to be equal to this. And again, you could have programmed this more efficiently than what I did. And I can pull all these things down. And you see what is happening. And the reason, one of the reasons this is called a bisection technique is notice that the error is decreasing by half each time. 0.25 is 1/2 of that. 1/8 is 1/2 of that. 1/2 of 1/8 is 1/16. 1/2 of 1/16 is 1/32, and so on and so forth. Okay, I'm going to pause. with this Excel, and I'm going to count to 10 Mississippi just in case anybody wants to ask questions or make comments or something like that. So I'm counting to 10 Mississippi now. Okay, I hit 10 Mississippi, so either I did a good job or you guys are good Excel programmers or something. Okay, so I'm going to lose XL, and we kind of did that problem, or at least a bit of that problem. Okay, we're going to discuss a different kind of problem, and I will share this. Okay, and when I say discuss, you might say, what the heck does that mean? So here is what discuss means. In fact, I'm going to change something. I'm going to put the words up here. Discuss the continuity Okay, well, okay, so this is y equals g of x, but you see it's defined piecewise. So for x bigger than or equal to, excuse me, not bigger than or equal to, x bigger than 4, it is this. So it is x squared minus 3x. Now, if you are bigger than 4, this is a polynomial, so this is continuous, because polynomials are continuous. And if x is less than or equal to 4, this is continuous because this is a line. This is 2x minus 5. So the interesting question, I suppose, is what happens when x is equal to 4? Because you see, if you're bigger than 4, you're good to go. It's continuous. If you are less than or equal to 4, you're good to go. But what happens at 4? And I really shouldn't say less than or equal to 4. If you're less than 4, you're good to go. But at 4, something funky might happen. Okay, so let's do some things. Okay, so what is g of 4? Well, g of 4, if we put 4 in there, we have 16 minus 12, we get 4. So I should maybe write that down. So I'm going to say g of 4, g of 4, and what did I say? 16 minus 12 is 4. Actually, g of 4 is not that, but if I plug 4 into the top equation, so I don't want to say. Ah, damn it. Okay. Note the top equation, plugging in 4. And we have no business plugging in 4 because it's the bottom equation that says it, but I'm just going to say, comma, we get. I think I said 4. 16 minus 12 is 4. Okay, so we get 4. This means that the limit from the right at x equal 4, we discussed one-sided limits on the videos and stuff, at x equal 4 is 4. But the limit from the left at x equal 4 is, if you plug 4 into there, and by the way, this is the value of 4. It is right continuous at that point, but if we put 4 in there, we get 8 minus 5 is 3. Well, the limit from the left and the limit from the right don't equal each other. So the function is continuous on using interval notation. I'm going to go from minus infinity. Oh, crap. I'm just going to say it differently. Is continuous everywhere except x equal 4, where there is a jump discontinuity. Okay, I'm going to pause for a count of 5 Mississippi, no, maybe 10 Mississippi. I do know what time it is, so don't worry. I haven't gone off the deep end here. I was counting to 10 so you guys could ask questions you have. Maybe no one had any questions, and that's okay. All right, let's look at the next problem. Okay, now here I'm going to ask you to start working this. I'm going to give you a small amount of time, maybe not enough time, but this actually is a question I have asked on tests before. So find a and b, and you see there's unknown constants a and b down there, so that this function is continuous on its entire domain. Okay, so everybody give this a go. I will give you a little bit of time to work on it, and then we'll discuss a solution, and then we'll be done. Okay, so go ahead and work on this for, I will give you, oh, I don't know, I will give you 2 minutes to do this. Go ahead. Okay, we're in our last minute, so let's just pause here. I'm not going to work the whole thing. In fact, I'll look at the solution if anybody wants to look at a solution. But what you have to do is you say, well, there's no problem being continuous for x less than or equal to -1 because it's just f of x is equal to 2. It's flat. You never have to lift your chalk. Similarly, for x bigger than or equal to 3, it's continuous because f of x is -2. But between here, what you have is you have a line connecting these, and you have to have coefficients a and b so that you never have to lift your chalk. So what we're going to do is we're going to say at -1, the limit from the left of this, excuse me, the limit from the right at -1 of this has to be 2. And similarly, on the other end, the limit from the left of this has to be -2. That's 2 equations in 2 unknowns, and you know how to solve 2 equations and 2 unknowns. So that's good. We didn't get into infinite limits, but I'm not worried about that. We're just fine. Okay, so now more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now more than ever, take care of yourself. Self-care is important, and of each other. We're all in this together. And next time we meet, we will be in a classroom. I'm stopping sharing, and I'm going to go back and do this. It is important for young people to be safe during the weekends, and so you all should be safe, and I'm stopping the recording.